Hello everyone. Today I'll be walking you through advanced process modeling from the book Fundamentals of Business Process Management by Marlon Dumas. This chapter takes what we learned earlier about modeling basic business processes and goes deeper in teaching us how to capture complex behaviors, exceptions, and event driven logic in BPMN. In simple terms, this chapter helps us make our process models more realistic, more like what actually happens in organizations. We'll talk about four big areas. One is how to model rework and repetition, two, how to handle different types of events, three, how to manage exceptions, and four, how to integrate business rules into processes. By the end, you'll see how all these make BPMN a truly powerful modeling language. Let's start with rework and repetition, something that happens all the time in real processes. Maybe a document is reviewed and sent back for corrections, that's rework. In BPMN, we can represent such loops in two main ways. The first is using a loop activity. This is a shorthand for a structured cycle that has one entry and one exit point. You can even annotate the condition like repeat until response approved. This keeps models clean and readable. However, when a process has multiple entry or exit points, for example, feedback can come from different steps, right? Then it becomes an unstructured cycle. These are harder to model but represent more flexible real world behavior. Sometimes we need repetition not sequentially but in parallel. Think of requesting quotes from multiple suppliers. You don't want to repeat the task 5 times manually. Instead, BPMN gives us the multi instance activity shown by three small vertical lines at the bottom of a task box. This means the same activity runs multiple times, either sequentially or simultaneously, depending on the context. For example, if we have a list of suppliers in a database, the process can dynamically send quote request to all of them at once and move forward once enough responses, say 5 out of 20. Next, we have ad hoc sub-processes used when tasks can happen in any order or even multiple times. They are marked with a tilde symbol. For instance, after placing an order, a customer might cancel, update their details, or check order status. And these actions can occur in any sequence before the order is fulfilled. Ad hoc sub-processes capture this kind of flexibility, what we call uncontrolled repetition. Now, let's move on to the events, which are the heartbeat of BPMN. An event represents something that happens instantaneously. It doesn't consume time like an activity does. There are three positions where events appear. Start events, where a process begins, intermediate events, things that happen in the middle, and end events, marking completion. We also differentiate between catching events and throwing events. Catching events is when which we wait for something to happen, and throwing events is when which actively send or signal something. One of the most common types is the message event, used when different participants exchange information. A start message event means the process begins when a message arrives, say an order email. An intermediate message event happens in the middle, maybe receiving confirmation or sending an update. And an end message event means the process finishes by sending a message like dispatching a shipment notice. Using message events makes diagrams clearer because they replace generic send or receive tasks with precise symbols. Another event type is the timer event, represented by a small clock icon. It's used to express delays or time based triggers. A start timer event could trigger a process every Friday morning or on the first of each month. An intermediate timer event makes the process wait, for example, waiting for 1 week before sending reminders. Timer events make BPMN ideal for modeling scheduled and recurring operations like billing cycles or monthly reporting. Sometimes two events might race each other. Whichever happens first determines what happens next. Imagine sending a shipment notice. If the delivery message arrives first, great, the process moves forward. But if a timer expires first, it triggers a shipment inquiry. This is modeled with an event based XOR gateway, shown as a pentagon inside a double circle. It's called a deferred choice because the process waits until one of the external events occur, not an internal data decision. Now, let's discuss how to handle exceptions, those rainy day scenarios. Exceptions occur when things don't go as planned. Maybe a payment fails or a product is out of stock. In BPMN, we have multiple ways to handle them: abort the process, catch internal or external errors, handle timeouts, or compensate for previous actions. Let's break these down one by one. Sometimes the best way to handle a failure is to stop everything. For that, BPMN provides the terminate end event, shown as a circle with a solid dot inside. When triggered, it immediately ends the process and any sub processes. For example, if a loan applicant has extremely high debt, the loan process is terminated right away instead of proceeding to later steps. Other times, you just want to handle an error within a process. That's done with error events. An end error event throws the error, and an intermediate catching error event attached to a sub process boundary catches it. Once caught, a recovery procedure begins. For instance, if raw materials are unavailable, the process triggers an out of stock error, interrupts the acquisition task, and then notifies the customer automatically. Not all problems come from inside the process, some are external. These are captured by boundary events attached to an activity. Example: while checking stock, the customer might cancel the order. A message boundary event catches that cancellation and redirects the flow to a cancellation procedure. Likewise, a timer boundary event can act as a timeout, interrupting a long running activity after a set period. Sometimes an external event shouldn't stop the main task. A non interrupting boundary event, shown with a dashed border, handles this. For instance, if a customer updates their address while their order is being processed, we can update their details in parallel without interrupting the main flow. This supports multitasking and improves flexibility. When an event can occur anytime during a process, we use an event sub-process. It looks like a dotted rounded rectangle inside the main process. For example, a customer might ask about their order status at any stage. The event sub-process handles that inquiry independently without affecting the main flow. It's especially useful when an event applies to the entire process rather than a specific activity. Sometimes, after an exception, we must undo things that already happened. That's where compensation comes in. Let's say we shipped a product but then the customer cancels. We might need to process a return and reimburse them. A throwing compensate event triggers the reversal, and a catching compensation event activates a special compensation task like refund payment or handle product payment return. This ensures we restore the system to a consistent state. Finally, business rules often drive processes. Instead of embedding rules inside decision tasks, BPMN lets us use unconditional events shown by a document icon. For instance, if stock level falls below threshold, then it's a trigger replenishment. The process pauses until the rule becomes true, then continues automatically. This integrates decision logic directly into process behavior. To summarize, this chapter gave us tools to handle complex and real world process logic. We learned loop and multi instance activities for rework and parallelism, ad hoc subprocesses for flexible task ordering, various event types, message, timer, and conditional, event based gateways for race conditions, exception handling through errors, boundary events, and compensation. These make BPMN expressive enough for both technical and business audiences. Here are the key ideas I'd like you to remember. Loops simplify repetition. Events make processes responsive. Gateways define choices and synchronization. Exception handling keeps models realistic. Compensation and conditions ensure business resilience. Together, they help us capture not just what should happen, but also what could happen in a process. So, in conclusion, to wrap this up, advanced process modeling is all about balance, combining control with flexibility, structure with adaptability. BPMN gives us a complete toolbox to represent human decisions and also system triggers and even failures in a clear and standardized way. Thank you for listening, and I hope this helps you see business process modeling as both an art and a science. Thank you.